So back at it here, lesson 1.3, conditional statements is the topic. Going to go ahead and do our quick notes here. And a real focus here, as previously mentioned, is that we are talking about conditional statements. So let's go ahead and define that. A conditional statement is an if-then statement. So really two parts to that, and we can most certainly go ahead and kind of sort of go back in some of these examples, and we can see the phrasing that occurs on the front side. How many times does the word if appear? If the score holds, if no additional goals, if Germany plays Denmark. So this repeats very, very frequently on the front side here. And this is really how a lot of different statements that we see in geometry kind of play itself out. Let's go ahead and define this a little bit further and differentiate between the first and second parts of that. Of course, there's the word if to lead off with. So if, we're just going to go ahead and toss in a blank. Let's go ahead and use the letter A there. And the word that appears behind, or the phrase that appears behind the word if, is referenced as a condition or a hypothesis. Then we have a phrase then, and that's not necessarily going to always appear itself, but we could always go ahead and add it in if we want. And we're going to go ahead and put whatever we have behind that, label it as the letter B, and that's going to be known as our conclusion. So situationally speaking, I'm going to go ahead and scroll up to the top again, just to kind of play this out. So we can see here the if a bunch of times in this scenario. So we have if the score holds, if no additional goals are made for the rest of the game, if Germany plays Denmark in the semifinal. In each of those sentences, we don't physically see the word then, but we could go ahead and toss it into a sentence, and it would be the same exact sentence. So then Germany will play Denmark in the semifinal. Then what will happen? Then can you say with certainty that the game ended 1-0 or the score held in that scenario? So these conditional statements, if then, most certainly playing out that way very frequently, even though sometimes we might have to add the word then in, and that's okay. We also want to kind of talk about this other concept that joins us here for the first time, which is a converse, which you might have noticed the Converse shoes at the beginning of this Nearpod. And the converse is kind of sort of the reverse of a conditional statement, where we have the conclusion in the front half and then the condition or the hypothesis second off. So we would see something that would appear like this. So again, just trying to color coordinate this. We would have if, and our conclusion comes into play first, then A. So if I take that conditional statement, if I flip it, then we would have a converse, and that's not necessarily always going to be a true phrase. So just because it involves that same condition hypothesis, that same conclusion, it's not necessarily always going to be a true statement. Doesn't necessarily work exactly like that. So you might have noticed up in the front side again of this piece of paper, we had a question like C, where we had a situation play out where the conclusion does not necessarily imply the condition. So it is most certainly a situation where it is not always true when we flip that and get that converse. Sometimes it is, though. Sometimes it most certainly is a scenario where something would work out in both directions, and we want to make note of that. And that phrasing there is known as biconditional statements. Maybe you're writing a little bit better than I am. Hopefully you are. Let me go ahead and highlight the prefix here, bi. So we know that bi is if you go back to the word bicycle, 2 wheels for a bicycle. Biconditional statements work in both directions. So a biconditional statement is true in both directions. And we do have labeling for that. We can draw an equal sign, put arrows on both sides of the equal signs. And that would be a situation where we could have A and B, if A, then B, and that be true. And then we flip it to the converse, and it would be if B, then A, and that would be true also. So both ways our statement would work.